Okay, so P8.2, forces between objects. And what we're going to be looking at here is something called Newton's third law. Now, quite a few of you already know what Newton's third law is, but the question is do you feel Newton's third law in your spleen? Okay, so Newton's third law. Now, every action has an equal and opposite reaction. But what on earth does that mean? Okay, well, I'll show you. So let's start off with an example of a bat hitting a ball. Okay, and you will know this if you've ever hit something, that if I hit the bat with the ball, then the action is on the ball, so that's the force on the ball, but that will create an equal and opposite reaction on the bat. Okay, so I can add my force arrows correctly to one to the bat and one to the ball, and they are going to be equal in size and opposite in direction. That's what equal and opposite means. And if you've ever tried to hit something, then you'll know that that's the case. If you ever tried to kick something, you know that's the case. So, for example, if you have two ice skaters, and this ice skater pushes this ice skater away, well then this person is also going to feel a force equal in size and opposite in direction to what they applied to this one. That's what equal and opposite means. Now, I think everyone's pretty okay with that one so far. Where it gets confusing is where you get some examples where it's very unbalanced in terms of what's happening. So the example I want to give is a fly hitting a car windscreen. Which one feels more force? The car or the fly? Okay, so you've got fly hits a car windscreen. Which one feels more force, the car or the fly? So the force on the car, well, if the fly's going that way, it's going to give a small force on the car. And the car's going this way, the car's only going to give the fly a very small force going that way. And if you look, they'll be equal and opposite magnitude. The difference is, it is much worse for the fly than it is for the car. And what people get confused by is cause and effect. Okay, so on this one, the cause is the same, but the effect is different. So it is the cause that is equal and opposite, not the effect. Okay, so that's the fly going through the window screen. Very bad news for the fly, just a little bit of mess for you on your window screen. So the next example I want to give you is of the moon orbiting the Earth. So we've got the moon orbiting the Earth, and you can all probably tell me that the force of gravity is acting on the moon and pulling it towards the Earth, and that is why the moon goes around the Earth. And most of you will also probably be able to tell me that the moon is pulling on the Earth back up, and that's why you have things like tides and things like that. Okay, but what people forget is that the force acting on the moon is exactly the same in magnitude as the force on the Earth. It's just in opposite directions. And the best explanation I've had of this is if we break the Earth and the moon down into their kilogram parts, and if I say I've got 1 kilogram of Earth here and 1 kilogram of moon here, I know that my 1 kilogram is going to be attracted to my 1 kilogram by exactly the same amounts. And then if I add another kilogram of Earth, because the Earth's bigger, well, that one is also going to be attracted to this one but also this one is now attracted to both of these, and those two forces add together. And if I do a third kilogram, then this one is now attracted to all three. And all three of these add up, and all three of these add up, and it becomes the same amount. Okay, so equal and opposite direction. So the cause is the same, but the effect is different. The effect of the moon on the Earth is just to cause tides and just to make it wobble a little. The effect of the Earth on the moon is to make the moon go around in orbit. But that is simply because the moon is so much smaller, it's easier to move. Okay, so that is Newton's third law.